Hello guys, welcome back. This course will cover everything you need to run your Dockerized application on AWS. To help you follow along, I will provide you with a sample Dockerized Laravel application built with an Nginx server. Before we get started, this is an advanced course. You should be fully comfortable using Docker and building Nginx servers. If you're completely new to Docker, I highly encourage you to watch my previous Docker courses first. Some of the topics we're going to cover are, but not limited to, Dockerized Laravel for production, GitHub, AWS authentication, AWS RDS for databases, AWS CodeBuild to build images, AWS Secret Manager to store secret Laravel environment variables, AWS ECR, AWS ECS for Elastic Container Service, AWS Security Groups and Permissions, Load Balancers for traffic management, AWS Route53 for domain configuration, AWS ACM for SSL Certificate. And you can see here, this is the website that I hosted. HTTPS is available, and this is Dockerized. Alright guys, you don't really need to use GitHub, but for this course, we're going to use GitHub to store our code repository. You could also use Bitbucket. So our first step is to create two new repositories. The first one, I'm going to call it Laravel-API. And we're going to make this repository private. Let's go ahead and create this. Now, let's go ahead and create another repository. So I'm going to actually open a new tab, and I'm going to create a new repository. Let's call this Laravel API-base-image. We'll talk more in details about these in the upcoming chapters. For now, let's set this to private and let's create this repository. In one of my last videos, we have implemented a top performance Laravel Docker build using Nginx and OP cache. Using that build, we were able to serve requests as fast as 5 milliseconds. If you haven't watched it, I highly encourage you to watch that first. Let's go ahead and pull our sample project. So we're going to search for Imad, Zamut, GitHub. And you want to go to my GitHub account, go to repositories and search for Laravel Docker AWS deployment course start. Go ahead and copy the link on the top here. Inside our terminal, I'm going to create a new project directory for us. So I'm going to call it Laravel deployment course. Let's go ahead and go inside our directory. And in here, we're going to make two new folders. One is going to be called Laravel-API. And another one called Laravel-API-base-image. Let's go ahead and go inside our Laravel API folder. And in here, let's go ahead and clone our project. So I'm going to write git clone, and we're going to paste our URL. And I want to clone it inside my current directory. So I'm going to add a dot in the end. Let's go ahead and open this in our code editor. In here, let's go ahead and copy our env.example file. And let's create our env file. So you want to rename it to .env. Go ahead and open your terminal and write make fresh to start our containers. All right, guys, once this is done, go ahead and open Docker. And you can see we have two containers running, one for our database, one for our server. We're exposing port 880. Let's give this a try. So in your browser, if you go to 127.0.0.1 at port 880, you should see the default Laravel web page. Let's go back to our code editor. Now for the Laravel API, let's go ahead and set it up with our GitHub account. So if you guys remember, we created two GitHub repositories, Laravel API and Laravel API base image. Let's go ahead and set this up. So I'm going to, in my terminal, let's go ahead and see what's happening. Git status. Let's make this a little bit bigger. All right, so the first step we're going to do is we're going to write rm-riv and remove our git file. Let's clear everything. Now we're going to write git init, and let's go back to our browser. In here, we want to copy this command. Let's do git add and dot to add everything. Let's do the commit. So I'm just going to copy this. Let's do the git branch. Let's create our main branch. Let's add our remote origin. And our last step, let's just push what we have so far. Let's do clear. And while we're at it, let's actually open up our other folder. So in the terminal, I'm going to go back. We created the Laravel API base image. Let's go and set that up as well. I'm going to open this in VS Code. And let's go ahead and open our terminal. And let's go back to our browser. We want to go to our base image repository and let's set this up as well. I'm just going to copy all this and I'll add it in here. All right, once that's done, let's just do a sanity check. So you want to refresh both of your repositories. You should see your files in here. I won't be spending too much time walking through our backend as we have already covered this in our previous Docker courses, but I'll give you guys a quick walkthrough. The first thing to note is we have a makefile, and a makefile has all the commands that we need to run our application locally. It just makes our life easier. Second, we have two Docker builds. So you have a Docker file and dockerfile.local. Same thing, Docker compose and Docker compose.local. The difference between local and the non-local ones is we use the local ones for our local environment. This is what we use when I run it on my computer. This one is for prod. So one of the differences here you can see is for our local one, we have two containers, one for database, one for API. For our production one, we only have API. That's because we won't be building our own database container. We will be using AWS RDS to create a cloud-based database. For the Docker file and dockerfile.local, same thing. The only difference is sometimes you want to install things on your local or on your prod that you don't want to have in either environments. So let's go to the production one. You can see it's pretty typical. We're installing PHP FPM. We're configuring some environment variables to configure OP cache to run on production. We're installing some dependencies, some PHP extensions, Composer. We're copying our configuration files. I have stored those inside our Docker folder. You have here Nginx. This is your Nginx configuration. And you also have the PHP ones as well. Then we pretty much, set up our application here. Then we run our entry point file. And the entry point file is inside our Docker folder. There's two of them, .local and the other one. And you can see here, we're installing Composer. And this is no dev flags. So this is one of the differences between the local one. So the local one, you install dev dependencies. Production, we don't. And we also do some optimizations here. And in here, we're copying our env.example file for local to env, or we copy env.prod to env. So we're creating our env file basically. We don't have the env prod so far. So we only have .env.example. We'll build this in our next chapters. And some other things we do is we run our migration here, we fix file ownerships, and then we run our servers. AWS CLI is a command line tool that we could use to manage our AWS services. For this course, we will use it mostly to authenticate our local environment with AWS Elastic Container Repository, which is what we will use to store our Docker images. To install it, it's very simple. You'll want to search for AWS CLI install, and it should be the first link on Google. And in here, you should see in the bottom the instructions to install it for your OS. If you're running WSL2 on Windows, make sure you install it inside your WSL2 container, not inside your Windows. You want to make sure you install it in the same place you run your Docker applications. So you would need to select the Linux instructions for those. And you'll just need to literally copy paste this command and run this, and you should be done. Once you have it installed, go ahead and run AWS 2- version. And if you have it installed, you should see your version here. I'm using 2.13. Before we start building anything in AWS, we will need to prepare our project for production. I already added make commands to run our application locally with the prod build. So you'll want to execute make fresh-prod. Now, while this runs, let's go ahead and create a new environment file. So let's go to our env file. You want to copy and paste this. Let's rename it to .env.prod. This is the env file that we will use for production. The first thing you want to do is you want to clear out your database values here. So just for now, remove the host, the database, the username, the password. In the app env, change it to prod. Debug, set it to false. And if you're using a domain, I would change this to your domain name. For now, let's keep it localhost. And yeah, that should be pretty much it. And it looks like here in the bottom that our build worked. So let's just open Docker and let's make sure that our container is running. And it looks like here we still have the database running from our local build, but shouldn't affect us. This is our Docker file here. Now for our database, we will be using AWS RDS to create a relational database. Let's go ahead and open our browser, and you want to search for AWS console, and go ahead and go to the first link. On the top right, click sign in. Once you're signed in, on the top, search for RDS. Should be the first result. Now in here, you want to go to databases, create database, and we're selecting MySQL, or you can select whatever database you're using for your project. Let's scroll down. And for the templates, it's very important that you select the free tier, unless you're really using a production app. I want to just show you guys something. Scroll down all the way. So with the default configuration, you're paying around almost 2000 USD. So you want to be very careful. Let's go ahead and go back up and select the free tier. And just by doing this, we basically reduced our cost to 15 USD. And obviously this is because we get a very much smaller server instance. Unless you guys are really getting a lot of traffic and you're using your database, there is no need for you to get an overpowered instance. So for the name, I'm going to call this prod-laravel-api. Now notice here, I'm naming mine with the prod keyword. This is because a lot of times with software companies, you might have a staging environment and you might also have a dev environment, and each one would have its own database. So you would have prod, Laravel API, staging, dev. So if you guys want to implement those environments as well, all what you have to do is pretty much do the same thing that we did for prod, but for dev and staging. Now let's scroll down. For the master username, you can keep it the same, but I'm going to call mine prod_Laravel_API. Now for this option, manage master credentials in AWS Secret Manager, you want to make sure you select this. So what this will do is AWS will create an entry in Secret Manager and manage this for you. And this will contain your password. It's important for us to use this option because we're going to actually read off the Secret Manager to get our password. The reason for this is it's not secure to store these values inside your env file. Now for the encryption key, we're going to keep the default option here. Scroll down, and for this, let's go ahead and select the smallest possible instance. Scroll down. You want to keep these at the minimum. Scroll down. Now guys, for the connectivity options, you want to make sure you give public access for this. You don't need to do this, and I don't recommend you do this for production database, but what this option will do is it will allow you to connect from your computer to your database. If you say no, then basically only the services created within your AWS VPC can access your database. So this would be more secure. But for this course purpose, let's go ahead and keep public access. And yeah, that should be pretty much it. Let's go ahead and create our database. Now you should be able to see it here. It's creating. Let's click on it. And let's wait until it finishes creating. All right, looks like it's done. You can see here, status is now available. Let's go ahead and retrieve our password. So on the top, I'm going to search for Secret Manager right here. So I'm going to open this on a new tab on the top, and you should see this entry here. Click on it, and this is your secret value here. So right here, if you click retrieve secret value, and you can see this is your username and this is your password. I'm going to open Notepad and I'm going to save these entries here for now. So I'm going to write database, username, and I'm going to copy the password. All right, to access our database, we need 3 pieces of information. We need the username, the password, and the IP address. Let's go back to our database. You should see the endpoint right here. Let's go ahead and copy this and let's add it in here. Now we need to create our database table. To do that, I'm going to open my database client. If you don't have a database client, you can use your terminal to connect to your database. I'm going to create a new connection, and it's pretty simple. I'm going to copy the endpoint, add it here, the username, and the password. Let's go ahead and open this, and here you go. Let's go ahead and create our database, and I'm going to call it prod-laravel-api. Let's go ahead and add that here. So the database was called prod-laravel-api. Now our final step, we're going to update our env file. So let's go back to our code editor, and you want to find your .env.prod, and let's go back to our notepad. Now we're going to set our database here. So let's go ahead and copy this. We called ours prod-laravel-api, and for the endpoint, let's copy this. So this would be your host here. Username and password are going to come from Secret Manager. I'm just gonna remove these. So let's comment them out, or you can delete them. And yeah, that should be it for this part. When you start running Docker builds in your pipelines, you may end up pulling Docker images from Docker Hub many times. A lot of people might not know this, but as of November 2020, rate limits went into effect. This means that each IP address is limited to 100 container pulls for anonymous users and 200 for authenticated free users per 6 hours. This is only for images stored on the Docker Hub. If you exceed this limit, you won't be able to pull images hosted on Docker Hub. Instead, you will get an error that says that you have reached your pull rate limit. You may increase the limit by authenticating and upgrading. To solve this problem, we will need to create and host our own Docker images instead of using images hosted in Docker Hub. The good news is once you do this, you will reduce your Docker image build times by at least 80%. Not just that it's much faster, it also consumes a lot less resources and build hours, which saves you a lot of money in the long run. To create our base image, let's go ahead and open our terminal. And we want to go inside our directory. I called mine Laravel deployment course. In here, we created a project in directory for Laravel API base image. Let's go ahead and go inside there. And I'm going to open this in VS Code. So for now, the only two things I need is our make file here and our Docker file. I'm going to copy those two and I'm going to add them here. For the make file, let's go ahead and erase everything right under help. Let's save this. For the Docker file, let's go ahead and erase everything right after installations. So right here, copy configuration files. We want to keep only all the things that we are installing. For example, PHP FPM. This image is coming from Docker Hub. Another example, Composer. See how I do copy and from Composer? So this image is also coming from Docker Hub. So just building this locally alone counts for 2 pulls. Now, if you're running this on your pipeline, you might be running this 100 times a day. You can see how you can greatly exceed those limits. So yeah, this would be our base image. It only has our basic installations. Let's go ahead and save these two. And let's go ahead and add our work and commit our changes. So I'm going to do git commit. And let's do git push. Now we're going to build this. So let's go ahead and write in the terminal docker build -t. So the -t will give it a name. For now, this is just to test it out. I'm just going to write test and we're going to add a dot to build whatever Docker files in our current directory. Looks like this is done. Let's go ahead and open our Docker interface and you want to go to images. In here, you should see your image. Mine is called test. Let's go ahead and try if this works. So let's go back to our code editor. And this time you want to open your Laravel-API project. Let's go to our Docker file. And in here, you want to remove all the installations. We already have this in our base image. For the image here, let's give our test one a try. So mine was called test. Let's save this. In the terminal, let's do make fresh -prod. All right, looks like it's done. And you guys can see how much faster this was. It only literally took less than 2-3 seconds for me to build all this. That's because all the heavy lifting, basically all the installations, are done inside your base image. And downloading everything from your base image is much faster than installing packages separately. To store our Docker images in AWS, we will need to create a new Elastic Container Repository. Let's go back to our browser, and in our AWS console, you want to search for ECR, and it should be the first result, Elastic Container Repository. Now on the left here, make sure you're inside repositories and go ahead and click Create Repository. For this one, we're gonna select private. Public means anyone can access it. Private, you will need to authenticate with AWS to access this. Let's go ahead and call it prod-laravel-api-base image. Now scroll down all the way and go ahead and click Create Repository. Now in here, you should see your repository. It's under private. Go ahead and open this. All right, guys, you can see here, so far we have no images. Nothing is pushed. On the top, if you click View Push Command, in here, you should see all the commands you need to run to push your base image. Now let's go ahead and go to our code editor. You want to go to your Laravel API base image project, and let's go ahead and go to our make file. In here, let's go ahead and add our commands. The first command I'm going to add is auth, and this one will authenticate us with AWS. And if you go back to your console here, you should find this first one. Let's paste this here, and you want to make sure you add a tab here. All right, let's give this a try. So in the terminal, I'm going to write make auth, and looks like everything worked. Login succeeded. Let's go ahead and add another command and call it build. And this one is going to build our prod image. Let's go back to our browser, and this is the command. You want to copy this. And let's go ahead and add a tab, and let's give this a try. So I'm going to write make build. Let's go back to our browser, and let's copy number 3. This is going to add a tag, and let's call this last command push. And let's say push to prod image. All right, let's paste this here. So this is the tag. Let's copy number 4. This is going to push the image. Let's give this a try. I'm going to write make push. Now, while this works, I'm going to add one more command actually. Let's call it build-push. And what this one will do is run both commands for us to build and push instead of running them one by one. So I'm going to run make build, then make push. And looks like here our image is done. It's pushed. Let's go ahead and go to our AWS. Let's refresh our page, and you should see this is your image. Let's go ahead and click on the latest one, and this would be the URL that you would use to access it. Let's actually copy this, and let's open up our Laravel API project in VS Code. So I'm going to open the terminal. I'm going to go to our Laravel deployment course folder inside our Laravel API. Let's open VS Code, and in here, instead of doing from test that we did in our last chapter, let's paste this URL. Now let's give this a try. I'm going to write make fresh-prod. Now, once this is done, let's go ahead and open our Docker interface. In here, you should see your container. AWS CodeBuild will allow us to create a build trigger for our AWS ECR repository. The trigger will pull our latest project files from GitHub, then build our Docker image in a click of a button or automatically once any code is merged on your main branch. So basically, you don't have to run all these commands manually. We'll just set it up so that once we merge any code to our main branch, it will all happen automatically. To do this, let's go back to AWS, and on the top, you want to search for code build. Now in here, you want to make sure you are under build projects, then go ahead and click create build project. For the project name, let's call it Laravel-API-base-image. And actually, let's add prod too. So prod-Laravel-API-base-image. All right, now scroll down and go to source. In here, you want to select GitHub. You can also select Bitbucket if you're using that. All right, now you have two options to connect to your GitHub account. You can use OAuth or a GitHub personal access token. I recommend you use OAuth. Right here, click connect to GitHub and go ahead and log into your GitHub account. Click sign in and confirm. Once that's done, you should see this repository URL. Click on this option, and in here, you should be able to see your repositories. Let's go ahead and search for ours. It's called Laravel-API-base-image. So right here, this one. All right, now that we're connected, scroll down. For the source version, you want to select your main branch here. So I'm going to write main. Scroll down. This part is optional, the primary source webhook event. If you want AWS to run the build every time code is pushed to your repository or basically merged to your main branch, you want to checkbox this option. In the event type, open this and you want to select push. Scroll down. For the environment, the operating system, let's go ahead and select Ubuntu. You can select whichever one you're comfortable with, but I recommend Amazon Linux 2 or Ubuntu. Now scroll down. For the runtime, select standard. For the image, select the latest one and scroll down. So here for the role name, just keep this in mind. We will come back to this later, but we have here a new role created for us. Later on, we will need to give this role access to AWS ECR so we could push code to our repository once we finish building our image. For now, let's skip it. Scroll down. All right, so for the build spec file, keep this first option selected, and then yeah, that should be it. Scroll down all the way and click create build project. All right guys, once this is done, you should see this page. On the top here, if you click on build projects, you should see all your repositories. So let's go back to ours and let's just trigger a build. It's not gonna work, it's gonna fail, but let's just see how it looks like. So right now we triggered a build and it's in progress. And in here, you should be able to see the log results of this in real time. If you click on phase details, you should see all the phases that it's going through. And you guys can see it failed on downloading source and it's saying YAML file doesn't exist. Let's go to build logs, and you should be able to see the logs here. And this one is saying YAML file doesn't exist. So we will need to create a build spec YAML file, which will give instructions to AWS on how to build our image. Let's go to our code editor for Laravel-API-base image, and let's create a new file here. Let's call it build spec spec.yml. Alright guys, now to make our life easier, let's go ahead and go back to our browser, go to Google and search for AWS build spec ref. For the first option, build specification reference for code build, click here. And this is the documentation for code build files. Let's go ahead and copy this. So scroll up and copy. Let's go to VS Code and let's paste this. Alright guys, before I go through this file, let's just clean it up quickly, make it a little bit cleaner. Let's erase the run as, let's erase the env, let's erase the proxy, the patch. You want to keep phases, close this here, and pretty much erase everything under reports, artifacts, and cache. Let's expand this back. Alright guys, so the first thing I want to explain is the phases. So when code build runs, these are all the phases that it goes through. Install, pre-build, build, and post-build. This is the first thing that runs. You use this to basically set your runtime versions like PHP or whatever you're trying to run. The pre-build runs before your build. This is basically where we do things as in authenticate with AWS. The build step is where we're going to build our containers. And the post-build, once everything is done and built, we're going to push our built image to ECR. So let's go ahead and expand all these options and start with the install. I'm going to remove the run as. On failure, you want to keep abort. Go ahead and remove this. If you select continue, it means basically if this step fails, you want to continue executing next steps. So keep abort. For the runtime versions, we're going to select PHP and our version is 8.2. Erase this one here. Now for the commands, this is where you can execute all the commands. For now, I'm just going to write echo and I'm going to just say install just to display a message. Let's go ahead and erase the finally. We don't really need it. Let's erase the steps. And let's do the same thing here. For the pre-build, let's remove this. Select abort. For the command, copy this here. Let's add this here. We're gonna echo pre-build instead. Let's remove the finally part. Let's copy this and let's add it for our build step. And let's echo build instead. Copy this again and let's add it inside our post build. And then let's echo post build instead. So we're just displaying messages here just to familiarize ourselves with what's running. Now let's go ahead and push our changes. So in our terminal, I'm going to do get add, get commit, and I'm going to say updated build spec. And let's go ahead and push our changes. So now this should trigger the build automatically actually. So let's go back to AWS. Let's go back to our build projects. Let's find our repository. You can see here it's in progress right now. Let's see what's happening there. Let's click here. You can see this is build number 2. Let's go to phases. All right, guys, looks like it's done for me. You can see these are all the different phases and these are ours. Install, pre-build, build, post-build, and let's go to build logs. If for some reason this takes forever to load with you guys, just refresh the page. But let's see. So here we can see everything. Running command echo install. We can see install, pre-build, build, post-build. Now let's go back to our code editor and let's actually start building this. So for the install phase, we pretty much just want to set the runtime version. So let's remove the commands. For the pre-build, we want to authenticate with AWS. So if you guys go back to your browser, search for ECR and click on your repository for your container, view push commands. Remember this. Let's go ahead and copy this. Let's go back to our code editor. And in here, I'm going to say logging in to Amazon ECR and I'm going to add 3 dots. So for the next command, let's paste ours here. Now for the build phase, let's go back to our browser and let's copy number 2 here. Let's go back here. Let's go ahead and add our command here. And let's go back and copy step 3. And that's going to give us a tag. Let's paste this here. Now, before we go further, do you guys see how we have the image name here? How we have the tag here? And how we have this value here as well. So what I want to do is I want to store those inside environment variables because I want to adjust these dynamically. I don't want to have to recode this file every single time something changes, maybe versions. To add these values, let's go back to AWS. Let's actually open another tab here. And you want to search for ECR. Now on the top here, you want to search for code build. Let's go ahead and go to our build trigger. On the top here, you want to click edit, then select environment. Now in here, you want to expand this section at the bottom, scroll down. You should see this part, environment variables. Let's go ahead and create 3 environment variables. The first one, I'm going to call it repository. Let's click add another environment variable. And this one, I'm going to call it image. And let's add one more. I'm going to say image underscore tag. Let's go back to our code editor. This prod-laravel-api-page image would be our image. So in here, we would set this value here. For the tag, it's basically this one. So you see here latest. All right, now for the repository, if you go back here, it should be this one right here, this URL. Copy this, let's go back here and let's add it here. Before we submit these changes, let's just go ahead and copy this repository here and let's use these variables. Let's find this URL here and let's replace it with a $sign and the variable name. Let's copy this here. Let's do the same thing here. Now let's go back to our browser. Let's copy image and let's do the same thing. Prod Laravel API base image. Let's replace it with a $sign and image. And let's do the same thing for this one here and this one here. Now let's do this one, the latest. So let's go back and copy image underscore tag and let's do the same thing here. So $sign, image tag, same thing here. Let's go back here and let's update our environments. Alright guys, now let's refresh our screen. Under build details, if you scroll down, under environment, if you click environment variables, you should find your environment variables here. Let's go back to our build spec file. Alright, so our final step is to push our changes. Let's go ahead and go back to our AWS. You want to go to your Elastic Container Repository. We're going to copy step 4 here. Let's go back to our code editor. And in here, let's go ahead and add our command. So for this value, this was our repository. So I'm just going to copy this and let's paste it here. Actually, before we do this, let's go ahead and add another command before we push. Let's do docker images ls -a, just so we could see the images in our log file before we push it. Let's give this a try. Let's do get add, get commit. I'm going to write a message, get push. This should trigger our pipeline. Let's go back to AWS. Let's go to CodeBuild and let's go back to our project. We should see it in progress. Let's open this. Let's go to build 3 and I'm going to go to phase details and let's wait for this. Alright guys, looks like our command failed at the pre-build phase. Let's just go to the logs, scroll down. We should see our error here. And I was completely expecting this. So if you look here, an error occurred, access denied. And what this is saying is basically this user is not authorized to perform this action on this resource. So to fix this is pretty easy. We just need to grant access. To grant our CodeBuild user access to ECR, let's go ahead and search on the top here. IAM, one word. Open this in a new tab on the top. Let's go to that. You want to go to roles. If you guys go back to our CodeBuild, you should see it in the log right here. CodeBuild prod Laravel base image service role. Copy this and it should be this one right here. Now in here, you want to click add permissions, attach policies, and you want to search for Amazon EC2 container, and let's just search for this. All right, so these are all the available options. You want to select this one, Amazon EC2 container registry power user. Click add permission. Now let's try this again. Let's try to rebuild. So click retry build, and I'm going to go to phase details and let's just wait for this. All right, looks like it's done. And here I have an error. Let's go ahead and check the logs, scroll down. And looks like here it's saying cannot connect to Docker. So for this, let's actually go back here. Let's copy our container name. On the top, click on build projects. Let's go ahead and delete this quickly. Let's write delete. Let's recreate it. Unfortunately, there's no way to do it other than recreate. So let's add our project name here. Let's go ahead and select GitHub. Then click on repository my GitHub account. And it was called Laravel-API base image. The source version was main. Let's add the webhook. And for the environment, let's go ahead and select Ubuntu, standard, image 7. And this is the part that we missed, privileged. You want to enable this flag if you want to build Docker images. For the service role, make sure we use our previous one. Mine was called prod Laravel API base image service role 1. Scroll down and yeah, that should be pretty much it. Click create project. And let's add our environment variables again. So let's go to environment, expand this section, and in here, let's add 3 variables. Let's go back to our project here and let's copy repository. Then we had image tag and we had image. Now to grab these values, go back to your Elastic Container Registry. In here, click on your latest one and you should find it right here. So this is repository, copy this. We want to add that inside our image. For the image tag, we were using latest right here. So this is the image tag. And for the URI, so we want to just copy this URL, not the whole thing, up to the .com part. And let's go back here and let's add this. Let's update this quickly and let's start our build. All right, looks like it's done, succeeded. Let's go ahead and check our build logs. And you can see there's all the logs here. Let's go down all the way. And we can see that we have here pushed our changes to our repository. Let's go back to our repository and let's refresh. And you should see it's pushed at this time here. Alright guys, now we want to do the same thing that we did for our base image, but for prod Laravel API project. On the top, let's go ahead and search for ECR. And in here, let's create a new repository and let's call it prod-laravel-api. And you want to set it to private. Scroll down, create repository. Now let's go ahead and search for CodeBuild. And let's do the same thing. Let's create a build project. Let's call this prod-laravel-api. Scroll down. For the source, you want to select GitHub, then select the second option, repository in my GitHub account, and search for Laravel-API. For the source version, select your main branch. Scroll down, add this, rebuild every time a code change is pushed. Scroll down, event type, set it to push. And for the environment, set it to Ubuntu, runtime standard, image, select the latest one. Enable privilege, let's not forget this again. And for the service role, there is no point to really create another role. So we're just going to use the existing service role. And that was the one that we created for prod Laravel API based image service role. And scroll down. Yeah, that should be it. Create project. Now let's add our environment variables. Click edit, environment. Now expand this section. Scroll down. Let's add 3 environment variables. The first one was our repository, then image tag. Let's copy this from our ECR. So in here, let's go to our prod Laravel API, view push commands, and let's grab them from here actually. So right here, let's copy this URL, copy, and let's add it in here. And this would be our repository, and this would be our image, and the latest would be our tag. Let's update this environment variable and let's go back to our code editor. For the base image, I'm just going to copy this spec file. And I'm going to open in VS Code my Laravel API project. Let's go ahead and paste it in here. And literally we can use this same file. We just need to add some modifications to it. For the install part, it's the same. The pre-build is also the same. But for the build, let's go ahead and copy our environment variable. So I'm going to copy .env.prod and create our env file. This should be the same. This is the same. Let's scroll down all the way. Yeah, that should be it. Let's try this out. So it should work automatically. I'm gonna do git add, git commit, added build spec, and let's push our changes. Let's go back to AWS and let's go to build projects. And you should see yours trigger automatically. Let's go ahead and open this. Now in here, click on your run. Let's just wait for this to finish. I'm gonna go to build phase. All right, guys, looks like it's done. I'm gonna check my logs quickly. Let's just scan through this. And looks like everything worked. Let's go back to our repository and let's refresh. We should see our latest one here. And here we go. It's right here. To run our Dockerized application on AWS, we need to create an ECS cluster. A cluster is basically a group of services. For example, if you're running more than one container, then each container would be its own service within your cluster. So your cluster is going to contain all the services that we're going to be creating. On the top here, search for ECS, Elastic Container Service. And on the left here, click on clusters, create cluster. And I'm going to call this cluster prod-laravel-api. Now scroll down and yeah, just go ahead and create this. Now that we have a cluster, we will need to create a task definition to run our application either as a task or a service. Task definition is a blueprint or configuration file that defines how a container should run within the ECS environment. This includes information such as port mapping, environment variables, Docker configuration, resource limits. We'll cover that later. Now, inside our AWS ECS dashboard, on the left, go ahead and go to task definitions. Now, once you're here, go ahead and click create new task definition. Let's call ours prod-laravel-api. For the image URL, we need to pull that from our repository. So let's search for ECR and let's go to our Elastic container. Let's find our prod Laravel API. Let's go to the latest tag and we want to copy this URL. Let's go back to ECS and let's add our image URL here. And I'm going to call this prod-laravel-api. Let's scroll down. And for now, let's click next. Now for the app environment here, we have two options. Either to use AWS Fargate or EC2 instance. Now, the only difference between these two is the Fargate AWS manages all the server instances. For the EC2, you have more control over the instance, so you could like SSH into it and do whatever you want. Now, these instances are what are used to run your Docker containers. For this course, I really don't see a purpose of selecting EC2. Again, the only difference is you can SSH into one and control it and the other one you don't. Let's keep this as the default. Let's scroll down and this is all our configuration, our CPU. Let's keep that the same. Now let's go ahead and scroll all the way down. That should be it. Click next. And again, you want to scroll down all the way and click create. So now we have our task definition. If you click here, you can see your task definition. Anytime you want to make change to your task definition, you select it here and you create a new revision. I'll explain this in a bit, but for now, let's click on our task definition here and let's go ahead and deploy this. Click here and click deploy. Now see here, you have two options. Create a service, run a task. A task is created when you run a task definition directly. This launches your containers until they are stopped or exit on their own, at which point they are not replaced automatically. So basically it's a one-time run. So it's ideal to run your application as a task for short-lived jobs such as crons or running scripts. It's important to point out tasks cannot be configured to use load balancers, so you can't really control traffic to them. Now, a service is like a task, but it is used to guarantee that you always have one or more instances running. If your container exits due to an error, ECS will automatically replace the failed task. Also, a service can be configured to use a load balancer. For this project, we want to run it as a service. Service is best suited for public-facing applications such as websites or APIs. Let's click service. And for the cluster, we're going to select our prod Laravel API. Scroll down. For the service name, let's call it prod-laravel-api. For the desired tasks, we're going to keep it 1. What this number here means is that AWS will launch 1 or whatever number you put here of this same task. Now, the reason why you would want to add more is if your website has a lot of traffic, you could serve a lot more instances. Let's just keep it for 1. Scroll down and click create. You can see here, your deployment is in progress. It should take a few minutes. If we go to clusters, if you click here, if you go to tasks, you should see ours running right here. Right now, it is provisioning. Let's go ahead and click here and let's wait for this to finish. All right, looks like now my service is running. Let's go ahead and on the left, click on clusters and you can see we have one running service. Let's click here and you can see your service in here. Let's go ahead and click on tasks and click on your running task. Okay, in here, you should see your IP address. Click open address. Let's test this out. All right, we're getting connection refused. That's because we exposed port 880. So on the browser, you want to just add port 880. Now let's go ahead and try making a change to our website and just see if it works. I'm going to open my Laravel API project. In here, on the left, you want to go to resources, views, welcome.blade.php. I'm just going to add a tag here. So let's add a text. So P, and let's just say test. Now in the terminal, let's commit our changes. So I'm going to do git add, git commit, add a message, and I'm going to push my changes. Let's go back to AWS. Now in here, I want you to search for CodeBuild. Now we're going to have to wait until our build is finished. Then we're going to redeploy our changes. All right, looks like it succeeded. Now let's go ahead and redeploy our changes. So you want to search for ECS, Elastic Container Service. In here, you want to go back to your cluster and click on your service. On the top here, update service. And you want to click force new deployment. Now scroll down all the way and click on update. In here, go to deployments, and you should be able to see this is our active instance right now. It has 100% of the traffic. It's running. And you see here, this is the new one. This is in progress. So once this instance is fully ready to handle traffic, this one will keep serving. Once the new one is served, this one will be deleted automatically. All right, looks like it's done. It took me around 5 to 10 minutes. You can see the old one was deleted, and now we only have the latest one here. All right, now let's go to tasks. In here, click on our running task, scroll down, and you can see here, this is our IP address, but this is actually different from the last IP address that we had. So each instance running in your cluster has a whole separate IP address. In the next chapters, we're going to be using an AWS load balancer to redirect our traffic to the proper instance using our domain name. But for now, let's go ahead and open this address and let's see our change. And don't forget to go to port 880. And we're going to configure the load balancer, by the way, so don't worry too much about the port 880 here. You can see this is our change. All right, guys. So if you remember, we created an env.prod file. So in here, we didn't add our username and password. So we want to inject environment variables using AWS Secret Manager for our application. To do that, let's go back to our AWS homepage, and you want to go to Secret Manager. Let's go ahead and find our Secret Manager entry and scroll down to secret value and click retrieve secret value. So if you guys see here, go to plain text. This would be the response of our secret value. So we have here username and password. Let's keep this open and let's open a new tab. In there, let's search for ECS. In here, you want to go to task definitions. Click on your task definition, click create new revision, and create new revision again. Scroll down under environment variables. Let's go ahead and add two keys. Let's go back to our VS Code. So the first one was called db_username. Let's copy this and add it here. And let's copy the password as well. For the value, you want to select value from. Same thing from here. Now for the value here, let's go back to our secret manager, scroll up, and you want to copy this secret ARN. For now, let's just open Notepad. Let's actually erase all this and let's add it in here. All right, let's go back to our AWS Secret Manager, scroll down, and see here you have two keys, username and you have password. To select one of these specific keys values, go back here. We want to modify this record. So let's just copy paste this 2 times and let's go all the way to the end right here. So the first thing we want to do is add a colon. Then we want to reference the variable. So let's start with the username. So add username here, then add 2 colons. And you want to do the same thing for the password. Colon, password, and 2 colons. Make sure you have the right spelling. So this is the password. Now let's go ahead and go back to ECS. So right here in this tab. And what we just created would be the value here. So I'm going to copy the username. And I'm going to copy the password. Let's scroll down all the way and let's go ahead and click create. So now we have a second revision. If you go back to task definitions, click here, say you have revision 1 and revision 2. So each change you make to your task definition is going to create a new revision. Now to apply this revision, we're going to go back to our cluster, click here, click on our service, update service on the top here. And you can see here where you select the revision. I'm going to select the latest one. And I'm also going to select the force new deployment. Let's go ahead and update this. And go to deployments. You should be able to see your task in progress right here. And it's using revision 2. Let's wait for this. All right, looks like it's done. Now we'll need to double check if it's actually working. So I already have my database client open and I did refresh. Previously, we never had those tables, but in our Docker entry point file, we are running our migrations and you should be able to see your migrations here. That's number 1. Or you could go to logs and in here, view in CloudWatch. I'm going to select the last 30 minutes and you should be able to see this is Composer downloading, installing. It should be right after Composer. Right here, creating migration table. So if you see this output, it means that your application can access your database. In AWS, a load balancer allows you to control and redirect network traffic across various resources. In our case, we will use a load balancer to create a unique DNS name and route both HTTP and HTTPS traffic to our application. Then we will set up an SSL certificate to enable HTTPS and configure our domain to redirect traffic to our load balancer. A target group is basically the configuration that defines where you want to direct traffic to in your load balancer. So basically the load balancer will redirect traffic to your selected target groups. Alright guys, let's go ahead and create our target group. On your AWS homepage on the top, search for EC2. Now inside your EC2 dashboard, scroll down all the way. You want to go to load balancing, click on load balancers, click on target groups, create target group. You want to select IP address. Now scroll down for the target group name. Let's call it prod-laravel-api HTTP. And this is going to expose port 80. Let's scroll down and go ahead and click next. For the IP address, you need to complete the last two digits. I'm just going to write 20 and this is for port 80. So I'm going to click include as pending below and you should see your entry here. Then click create target group. Now let's go ahead and create our load balancer. On the left here, scroll down all the way. Under load balancing, click load balancers. Then create load balancer. Select the application one. For the name, I'm going to call mine prod-laravel-api, and this is going to be internet facing. Scroll down, you need to select two availability zones and scroll down all the way. For the listeners, we want to select our target group on port 80. Now scroll down all the way and click create load balancer. All right, now it's provisioning, so let's give it a few minutes. All right, it took me around a few minutes, but you should eventually see it become active. Now we need to reconfigure our AWS ECS application to use our load balancer. So let's on the top search for ECS and you want to go to your cluster. Let's go to our service. Let's click update. Now let's go ahead and set the desired tasks to 0 so we could delete our instance. And let's go back to clusters. Let's go here. Let's select our service and let's delete it. All right, guys, now we just need to wait until this draining part becomes 0. And you can see after a few more minutes, this is gone. Now let's go ahead and go to our task definition. And this is very important part. You want to first create a new revision. And in here for the port mappings, you want to make sure you select the port that's exposed for your Docker container. Make sure this is 80 because for our application, I set it to 880. Once you set this to the correct port that's exposed on your Docker containers, mine is 880. You want to scroll down all the way and create. Let's go ahead and deploy a new service. I'm going to choose our same cluster, scroll down. For the service name, I'm going to call it prod-laravel-api. Scroll down all the way. For the load balancing part, let's go ahead and select the application load balancer. We want to use an existing load balancer. Let's select the one that we just created. And for this part, you want to make sure you have the correct ports in here. For the template project that we're using, we exposed port 880. Here, for the listener, you want to use an existing one. This one, we want to use an existing target group as well. And let's go ahead and create this. And if you guys want to track your deployments in real time, you could just click here, view in CloudFormation. And on the meantime, I'm going to go back to my cluster. And in here, I'm just going to monitor this. I'm just going to close this and let's go back to our cluster. In here, you want to go to tasks. Let's go to our task and let's try our IP address. And we exposed port 880. Let's try that. And here we go. Now let's try to access this through our load balancer. So in here, you want to search for EC2, scroll all the way down on the left, and you want to go to your load balancer, click here, and let's try this DNS name. Copy, and let's paste it in here. All right, now looks like here we're getting an error. So whenever you have a new domain name, whether it's your application load balancer or a real domain name, there's something called DNS propagation. Whenever you make changes to any IP address that's pointing to a DNS, it takes time to update across all the servers on the internet. So you will not see your changes immediately. It just takes a little bit of time, sometimes half an hour to an hour to even a little bit more. Alright guys, now looks like for me, my DNS name for my load balancer is working. It took me around 40 minutes of waiting. To enable HTTPS access, we will need to purchase a domain. If you don't have a domain, you can purchase one in AWS by going to Route53. In here, you wanna click on register domains on the left. And in here, go ahead and click register domain. And it's very straightforward from here, guys. You could search whatever domain name you like. Let's try this. And pretty much select and proceed to checkout. Once you purchase this domain, it should take few hours, but then you should have a hosted zone. So if you click here, you should have a hosted zone that would look like this. Once your domain purchase is complete and your domain is ready to use, go back to AWS Route53. In here, click on hosted zones and you want to click on your domain. All right, now let's open another AWS screen on another tab and you want to search for your load balancer. So go to EC2, scroll down all the way, go to load balancers. Let's click here and let's copy our DNS name here. Let's go back to our Route53 hosted zone and let's create a new record. So for the first one, we're going to map this domain name, justtms.com, to an alias. And you want to choose the endpoint. And in here, you should have an option for your load balancer. Click here. For the region, make sure you select your correct one. I am in US East 1. So I'm going to search US East 1. And again, you guys need to make sure you are in the correct region. For our load balancer, let's select that and create record. Now let's create another record to map the www version of our website to the non-triple version. So click on the alias here and select the first option, alias to another record in this hosted zone. We want to choose the record and we're selecting the regular version of our website, justtms.com. Let's create this record and let's give this a try. Again, with DNS propagation, it should take time. Now we need to enable HTTP access to our website. Let's try this out. All right, you guys can see when I try to access my website with HTTPS, I get this error. Let's fix this. So let's go back to AWS and you wanna search for ACM and you should find Certificate Manager, not the first option, this one, Certificate Manager. And you wanna click request a certificate, then click next. And in here, you wanna write your domain name. Mine is justtms.com and might as well add the www version. And actually, let's change this to the wildcard star. So if you have any subdomains, it would just work. For the validation method, you can select DNS or email. Honestly, this is the easiest one. And scroll down all the way and click request. Now refresh the web page here. You should see this entry and it should say pending validation. This should take a little bit of time. Let's click here. So in here where it says domains, click create records in Route53. And AWS will do this automatically for us. All right, now that's done. To configure HTTP access for our website, we need to configure our load balancer to use our new ACM SSL certificate. Inside your AWS Certificate Manager, once yours is issued, so you should be in the green, you want to search for EC2. Now let's go to our load balancer and let's click here. Under listeners and rules, scroll down and click add listener. We're going to add a new listener, but this time it's for HTTPS on port 443. For the listener setting, let's set our certificate. Now scroll down. In here in the bottom where it says ACM, you want to select your new certificate. Now let's go ahead and add this. Looks like we need to select a target group. Let's go ahead and select our prod Laravel API HTTP. All right, once this is created, let's give this a try. So I'm going back to my website. Let's refresh. And you should see now it should work when you try to access it via HTTPS. Let's click here. Let's go to connection is secure. Let's check the certification. So you should be able to see all this information. It's from Amazon. Our last step is to redirect HTTP traffic to HTTPS using our load balancer. Let's go back to our load balancer. Scroll down all the way where it says HTTP 80. Click here and edit listener. Instead of doing forward to target groups here, we want to redirect to URL. In here, you want to make sure you have HTTPS selected and 301 here. Let's go ahead and save our change. And that should be pretty much it. Let's give it a try. So you'll want to open another browser, because if you accessed your website with HTTPS in Chrome, for example, it will automatically be cached. So you'll be redirected to the HTTPS version automatically, regardless if your website is set for it or not. This is a feature in Google Chrome. We want to avoid this when we want to test our website redirection. Let's try it here. So I'm going to do HTTP, justtms.com. And here we go, we got redirected to our HTTPS version. Thank you for watching. If you found this tutorial useful, then give it a thumbs up. Making content like this, guys, takes a lot of time and effort. If you want to help me out, consider sharing my videos and spreading the word. I'll be releasing another video to show you how to create a CI/CD pipeline to automatically trigger deployments and split traffic. Also, don't forget to subscribe to my channel to stay up to date with my latest training series. We'll see you guys on the next video.